Yesterday we have discussed series system and parallel system, and we have obtained the structure function of series system and parallel system. Another example is k out of n system. That means if at least k number of components are working, the system will be in working. At least k number of components are in working, then system will be also in working condition. For example, when your computer lab, there are 4 or 5 number of batteries are there. If at least 2 batteries are working, then the system will be working. Okay, that is a typical example. The structure function can be written as phi of x equal to 1, system is working, if summation xi equal to greater than or equal to k, and equal to 0 is summation. I will show you in some this is x1, this is x2, this is x3, this is 5. Suppose this is 2 out of 3 system. That means at least 2 components are working, then system will be working. For example, here, suppose the component 1 is functioning, 2 is functioning, 3 is functioning, then system will automatically in function status. Okay. And suppose other case, one first component is component is working, third component is failed, again system will be in working. Okay. First component is working, second is failed, third component is working, then system will be in working. Okay. First component failed, second component is working, third component is working, then system will be in working. This is 2 out of 3 system. At least 2 number of components are required for system functioning. And if first component is working, second is failed, and third failed, the system will be in failed stage. First component is failed state, second component working, third component failed state, then system will be in failed state. First component failed state, second is failed state, third component only in working, then the system is also in failed state. Sorry. Okay. So this is an example for 2 out of 3 system. Okay. So that means what happens here? Yeah, it is insert one row. Let us take the sum plus okay. And what is the sum? Yeah, 3, 2, 2, 2, 2. So what is our condition? Our condition is x1 plus x2 plus x3 greater than or equal to 2. So that is our condition. Okay. The condition satisfied for these 3 cases. Condition satisfied for these 3 cases. So in that case, the system is functioning, no problem. System is functioning. Hello? Paray. അത് മുകളിൽ തന്നെ ഇട്ടാ അത്ര പേരില്ലേ, 120 പേരില്ലേ? അല്ല, അതിൽ 50 കുട്ടികളല്ലേ ഉള്ളൂ, രാവിലെ 50 അല്ലാതെ നമുക്ക് എവിടെ ഇടാനാ? അവർ 50 പേരേ ഉള്ളൂ. പിന്നിലത്തെ നമ്പർ ഇട്ടോ, അത് കുഴപ്പമില്ല. ബാക്കി അപ്പൊ അത് കഴിഞ്ഞിട്ട് കിട്ടാ മതി. അതൊക്കെ കിട്ടും, അതൊന്നും കുഴപ്പമില്ല. അതൊക്കെ നമ്മുടെ ഇതിൽപ്പെട്ടാ. Okay. Okay. അപ്പോൾ ഇവിടെ പോയി. So സക്രേട്ടാ, ആ അല്ലല്ല, മോളത്തെ ഹാള്. ആ അത് കഴിഞ്ഞിട്ട് ഉടനെ തന്നെ ആ ചേച്ചിമാരോട് പറയണം തുളയ്ക്കാൻ, അവർ കുട്ടികൾ ഇരുന്ന ഭാഗം ആ ഹോളാക്കി മാറ്റിയിട്ടുണ്ട്. ആ ചേച്ചിമാരോട് പറഞ്ഞു വെക്കണം കേട്ടോ, അവർ കഴിയുന്ന ഉടനെ തുടയ്ക്കാൻ പറയണേ. ആ 12:30 അവർ റെഡിയായി നിൽക്കാൻ പറയണം ചേച്ചിമാരോട്. ഓക്കെ. Okay. So let us consider radio system. Next we consider radio system. You can, yeah. This is a structural representation of 2 out of 3 systems. We can look in that structure. So another is radio system, where there are 5 components. One is tuner, changer, amplifier, then speaker 1 and speaker 2. This is tuner, changer, amplifier, speaker 1, speaker 2. Okay, it is mentioned here. So what is the we'll draw in this okay, this is okay, 1 2 3 5. Okay, this is a structure. X1 tuner, X2 changer, amplifier X3, speaker 1, speaker 2. Okay, that is actually the figure given here. Let us consider, suppose tuner is working, changer is working, amplifier is working, speaker 1 is working, speaker 2 is working, then system will be also in working. Okay, suppose tuner is failed, changer is working, amplifier is working, speaker 1 is working, speaker 2 is working. Then also from this figure it is clear that through tuner it can work. Tuner, amplifier, sorry, changer, amplifier, speaker 1, speaker 2. Okay, so system will be working. Another situation is tuner working, changer 0, 1, 1, 1. Then again, another situation is 1, 1, 0. If amplifier is in failed state, what happens? System will be in failed state. Okay. Tuner is working, changer is working, amplifier is speaker. Speaker 1 is failed, speaker 2 is working, and also system is working. Okay. Then this is working, 0. Then also system working. Now let us take two components. 0, 0, 1, 1, 1. What happens? No input is available to amplify, so the system will be in failed state. So input will be only through tuner and changer. Then 0, 1, 0, 1, 1. Then amplifier is failed, so system will be in failed state. 0, 1, 1, 0, 1. Only changer working, amplifier working, one speaker is working. The system will be working. Another is universal system working. There is 1, 0, 0, 1, 1. Amplifier is failed, the system will be failed. 1, 0, 1, 0, 1. Amplifier is working, one speaker working, yeah, it is working. 1, 0, 1, 1, 0. And also system is working. Zero. 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 Now we will have 3 zeros. ഇത് കഴിഞ്ഞ് ഇതെടുത്തിട്ട് ഇതിൻ്റെ എന്താ വരിക? ഇതിൻ്റെ 0 വരും, ഇതിൻ്റെ 0, ഇതിൻ്റെ 0, 0. പിന്നെ 3 0, അപ്പോൾ 4 0, അതായത് ഒരു 1 ഉള്ള ഒരു കഴിഞ്ഞ് ഒരു 0 ഉള്ളത്. ലാസ്റ്റ് എല്ലാം 0 എന്ന് പറഞ്ഞു. Okay, so there are 32 configurations in which 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 configurations are configuration there with phi equal to 1. Okay. Out of there are 32 configurations. 32. 33 means one is heading. 33 vectors. 33 vectors in such a way that among 32 vectors, 9 are in functioning stages. 9 vectors are supporting the system for the functioning. Okay. So this is we have to keep this one because we have to analyze the importance of each component using this configuration. So I keep this one. So I need to study in the coming classes. Okay. Radio system. So what I'm saying is, yeah, we can see that this is a radio system, tuner, changer, amplifier, speaker 2, and we could draw the configurations in such a way that the radio system is functioning or system is failed. Okay, what will be the structure function? You know, the structure function of series system is product I from 1 to n xi, and the structure function of parallel system is, what is that? Parallel system is union I from 1 to n xi. So this is not a series system, not a parallel system. It is a parallel series system. It is a parallel series system. Okay, so we can consider. Yeah, this is a single system. A minute. Okay. This is a single unit. Okay. Again, we can consider this as a single unit. Again, we can consider this as a single unit. So these modules, these are usually called modules. These modules are connected in series. Okay. So what will be the structure function of this module that you can draw? What will be the structure? This is in parallel. Okay. So what will be the structure function of first module? Yeah, that is x1 union x2, because we have used the union notation. What is x value? X1 union x2, that is nothing but 1 minus x1 into 1 minus x2. Okay. So the structure function of this first module is x1 union x2, that equal to 1 minus x1 into 1 minus x2. This is the second module, that is just a single command, so there's just we can write it as x3. That is the structure function of third module, x4 union x5, that is nothing but 1 minus x4 into 1 minus x5. Okay. At the same time, these modules are connected in series. So what will be the structure function? Can you say that? The entire structure function will be, what is that? Yeah, phi equal to phi of x1 comma x2 comma x3 comma x4 comma x5 equal to, what is that? What is that? These three modules are series, so we can take the product of x1 union x2, that is the first module structure. Then x3. Again, third module structure is x4 union x5. So this is the structure function product of these three terms. We can substitute the right hand side of this x1 union x2 and x4 union x5, and we will get the expression like this. Yeah, it is displayed here. It is not clear at the same time. That is written in this page. No problem. Okay. So we have obtain the structure function of radius system. In a similar way, we can find out the structure function of any complicated system. We can subdivide into series structure or parallel structure, and thereafter we can find the structure of individual series structure or parallel structure, and then pull the entire modules into a series structure or a parallel structure. So that is the usual procedure adopted by the reliability engineers for obtaining the structure function of a complicated system. Okay, engineers are usually doing the analysis of structure function. They are not doing with some other formulas or using some other theorems, etc. They are, first of all, they will find out the structure function of the system, and using that structure function they will analyze. And now there is one definition, that is it is a vector notation. I will show that vector notation there. Okay. X dot comma dot I, small I, is exactly equal to, what is that? X1 comma X2 comma etc. Ith component is in 1. Sorry, ith component is in state dot I comma etc. xn. This is one notation. Don't worry about that. When ith component is functioning, it will denote as 1i. Okay, so here we will write this as 1i. If ith component is in failed state, we will denote as 0i. So in that case, the notation will be like this. So these are some notations. Okay, that is displayed here. And a component is called relevant. Relevant means if the state of the component changes, then the system will also changes. System state will be also changing. Okay, that means a component I is called relevant. This is y. Okay, phi of x1, x2, xn equal to phi of xn, etc. Okay. The component I is irrelevant when the component changes from 0 to 1. There is no change shows in system structure. So that means the component is irrelevant. There is no relevancy for that component, because when the component changes from 0 to 1, there is no change in system. And then if it is equal for every combination of x1, x2, etc., xn. If it is equal, if this equality holds for every combination, because x1 can change, x2 can change, etc., xn can change. So in all changes, if this equality holds, then we can say that ith component is irrelevant. അതിന് പ്രത്യേകിച്ച് പ്രയോജനമൊന്നുമില്ല. അത് ഫെയിൽഡ് ആയാലും ഫങ്ഷനിങ് ആണെങ്കിലും സിസ്റ്റത്തിൽ ഒരു മാറ്റം വരുന്നില്ല. ഓക്കെ, so what will be the condition of relevancy? Yeah, what will be the condition of relevancy? A component I will be relevant when it is not equal to phi of x1 x2 x 1i comma x to xn not equal to phi of x1 x2 etc x naught x0i etc xn for at least one combination, for at least one x1 x2 xn combination. In the above line we have to put the condition that for all the combination x1 x2 xn. In the below line we have to put the condition that for at least one x1 x2 xn, if this is not equal to phi of 1i is not equal to phi of 0i, then the ith component will be relevant. Okay, so that is the condition mentioned here. Phi of 1i comma x not equal to phi of 0i comma x. Okay, for already dot I comma x. Otherwise the component is relevant to the structures. Okay, let us stop here today. We shall discuss some lemma and result in the next class. I think I can give you through WhatsApp the proof of that lemma. Here we can see the just definition only. I will give you the proof through the WhatsApp group, no problem. Anyway, you study up to this two examples and the relevancy, definition of relevancy. Okay.
Okay, sir.
Okay. 32 കോമ്പിനേഷൻ നിങ്ങളത് നോട്ട് ചെയ്ത് വെക്കണം. ഞാനത് റെക്കോർഡ് ചെയ്തിട്ടുണ്ട്.